heating effects of electric current. The electrical work done by the cell is given by W equal to VQ. Q is equal to IT, current into time. Hence, W equal to VIT. This is the work done by the cell to pass I current in the conductor. Similarly, V is equal to IR. Substitute here. W equal to IR into I into T implies W equal to I square RT. Similarly, from same V equal to IR relation, I is equal to V by R. Substitute here. Then W equal to V square by R square into R T. 1 R cancel. W equal to V square T by R. Like that, different forms of work done by the cell. One is W equal to VQ. Second one is W equal to VIT. Third one is W is I square RT. Fourth one is W is equal to V square T by R. These all are the expressions for work done by the cell. Work done is equal to potential difference V into charge Q. Potential difference into charge. Therefore, W is equal to VQ, first formula. Next, W equal to VIT. Why? Because Q equal to IT. But V is equal to IR. Means W equal to I square RT. Again, from the same expression, I is writing as V by R. Then W is equal to V square T by R. These are all the formulas for work done by the cell. This work done is converted into heat in the resistor. So, whatever the formulas now we find for work done, what are that? W equal to VQ, W equal to VIT, W equal to I square RT, W equal to V square T by R. All these formulas are used for heat also. Whatever the work done by the cell is converted into heat in the resistor. So, all the work done formulas is equal to heat. H equal to VIT, I square RT, V square T by R. Now, electric power. Rate of doing work is power. So, electric power is the electrical work done per unit time. Power is equal to electrical work done W by time T. Therefore, P is equal to W formulas are what? VIT, I square RT, V square T by R. All the formulas substitute here in place of this work done. Then VIT by T, TT cancel. VI. But W equal to one more formula is also there. What is W? I square RT. Hence, power equal to I square RT by T. Again, TT cancel, I square R left. Is equal to I square R. Like that, work done is equal to V square T by R. Then power is equal to V square T by R by T. TT cancel. V square by R. So, these are the different formulas for power. What is power? The electric work done per unit time is called electrical power. SI unit of power is joule per second. Work done by time. Work done measured in joule, time in second. So joule per second also called watt. Here W equal to V square T by R by TT cancel V square by R you are getting. The rate of transfer of electrical energy by an electric circuit per unit time is called the electric power. Amount of electrical energy, that is work done by an electrical circuit per unit time T equal to 1 second. That rate of transfer of electrical energy by an electric circuit per unit time is called the electrical power. Electric power definition. It is the rate at which work is done or energy is transferred in an electric circuit. Work done per unit time, W by T. What is W? The rate at which work is done or energy is transferred. Rate you are saying means W by T. Work done rate. The rate of doing work is the power. Here, rate at which work is done or energy is transferred in an electric circuit, that we call electric power. Next, here SI unit of the power is joule per second, that is watt. The commercial unit of electrical energy is the kilowatt hour, which also known as Board of Trade Unit, BOT. 1 kilowatt hour is considered as 1 unit. So what is the value of 1 kilowatt hour? 1 kilowatt hour. Kilo means 1000. Hour contains 60 minutes. 1 minute contains 60 seconds. That means 1000 into 60 into 60. Now watt converts as watt, hour as second. Now watt second is nothing but joule. So 1 kilowatt hour is equal to 6 into 6, 36 into 1, 2, 3, 4, 5. 10 power 5 watt second or joule. 1 kilowatt hour is called as 1 unit. 1 unit is what? An amount of electrical energy 36 into 10 power 5 joules is taken as 1 unit. That we call as 1 kilowatt hour. What is 1 kilowatt hour value? 36 into 10 power 5 joules. Next one. Electrical energy. Electrical energy is the work done by the electric current in a given time. So electrical energy equal to electrical power into time. What are the formulas are there for power? Means P equal to voltage into current, VI. P equal to V square by R. P equal to I square R. R formulas is used here. Then W equal to power into delta T. Delta W equal to VI power into delta T, delta T. Next, power. The energy dissipated per unit time, usually rate of work done or rate of energy dissipated. That here defined as the energy dissipated per unit time is the power dissipated. P equal to delta W by delta T. P equal to IV, already we derived it. Using Ohm's law, V equal to IR, substituted in this, we get I square R V square by R as power. I square R V square by capital R. is the power, where capital R is the resistance of the given conductor and V is the applied potential difference. Then the power is I square R. One more formula is V square by R. This power loss in a conductor R carries a current I. Now, power transmission. Usually, electrical power is transmitted from power station to homes and factories, which may be hundreds of miles away via transmission cables. This power is transmitted from power station to home or factories. One obviously wants to reduce the power loss in the transmission of cables. The electric power transmitted hundreds of miles via conducting cables. So during this process, some amount of heat is lost. So anybody want to reduce that power loss in the transmission of electric power through the cable. Consider a device R to which a power P is to be delivered via transmission cables having a resistance RC. That means cable resistance is RC. The device resistance is capital R. You want to convert a power of P to be delivered via transmission cable. That's why the cable also having some amount of resistance. That resistance RC. Then finally, V is the voltage across R and I is the current through it. Then power equal to VI. V is the potential difference, I is the current. The connecting wire from the power station to the device has a finite resistance RC. Then the power dissipated in the connecting wire is P in the connecting wire, PC, which is equal to I square into RC. What is I? Current in that conducting wire. That is PC equal to P square RC by V2. To reduce this power loss, these wires carry current at enormous value of voltage. This is the reason for the high voltage danger signals on transmission lines. Here, electric cable lines has a danger sign. Why? Because high enormous amount of current carry current at enormous values of V. This is the reason why danger signs on the transmission lines. A common sight as we move away from the populated areas that we know. Using electricity at such voltage is one safe and hence a device is called transformer. Lowers to a suitable voltage for us. That means there, for example, an electrical energy is developed at 2200 volt at the power station. But in our home, we use 220 volt. Means that 2200 volt converts into lower suitable value for household purpose, that is 220 volt. For this purpose, we use a device which we call as transformer. Transformer is a device which is used to lower the voltage. MCQ. The SI unit of electric power. What is the SI unit of electric power? Options are joule, joule per second, watt, both 2 and 3. Both 2 and 3 are correct. Why? Because joule per second is also watt. Now problems based on electric power. A house is fitted with 10 lamps of each 60 watt. Each lamp burns for 5 hours a day on an average. The cost consumption in a month of 30 days at 2 rupees 80 paisa per 1 unit. So 60 watt lamps. How many are using? 10 lamps. Each works for 5 hours of time. Then the cost consumption we are going to find. Options are current bill they are asking. The options are rupees 132 rupees,